So, I know I've been gone for a while, but anyways, I have downloaded this thing called Kaggle, and I'm going to be doing some exercises on it. This is kind of like the times when I did the, FreeCodeCamp and Khan Academy. I'll post a link to Kaggle down below if you want to try it out. And the exercises I will be doing are like, deep learning, because that's what I'm learning. Okay, never mind. So, this notebook is an exercise into the Intro to Deep Learning course. You can reference the tutorial. Okay, I can't read. In the tutorial, you learned about the building blocks of neural networks, linear units. We saw that model of just one linear unit will fit a linear function to a dataset equivalent to linear regression. In this exercise, you'll build a linear model and get some practice working with models in Keras. I won't be looking at the introduction, like the thing that they show you before the exercise, because it's literally just them teaching you about the topics. I want to show you guys things that I do. Come on. Start, please. It takes a while. Okay, I'm not sure. Is it running? Okay, is it ready? Okay, I think it's ready. First few rows. The red wine quality dataset consists of physiochemical measurements from about 1,600 Portuguese red wines. Also included is a quality rating for each wine from blind taste tests. Okay, run. First few rows of this dataset. The 5 rows, we start at 0 counting in programming. You can get the number of rows and columns or a NumPy array with the shape attribute. What if we uncomment this? Will this do anything? Okay, yeah, that definitely does something. Then why put it there? Okay, never mind. Oh, wait, okay, yeah, they're telling us that this is gonna show us the rows and columns. My bad. Okay. How well can we predict a wine's perceived quality from the physiochemical measurements? The target is quality, and the remaining columns are the features. How would you set the input shape parameter for a Keras model on this task? Okay, so I'm not really good at this. So target is quality. Okay. Target is quality, and the remaining columns are the features. Input shape parameter for a Keras model. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What if we 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I don't know what I was counting actually. Okay, let's try 12 first. Remember that you should not count the target when determining the value for input shape. How many columns are there excluding? Oh, wait, okay, we don't want quality? So it's 11. Okay. Define a linear model appropriate for this task. Pay attention to how many inputs the model should have. Okay. So the type of model they taught was that's the layer model. I think. Yeah, that's the layer model. Let's see. Units is the outputs, I think. inputs. They're like, I'm just going back and forth here. They're the rows, right? And the columns are the inputs? Right? I might be getting this like completely wrong. Oh yeah, and then we do the input shape. What did I, shape? Don't ask. Oh, single layer. Okay, that's the units. Hey! Okay. Keras represents the weights of a neural network. Neural network with tensors. I'm fine. Tensors are basically TensorFlow's version of a NumPy array with a few differences that make them better suited to deep learning. One of the most important is that tensors are compatible GPU and TPU accelerators. TPUs, in fact, are designed specifically for tensor computations. Okay. A model's weights are kept in its weights attributes as a list of tensors. Okay, I'm fine. Get the weights of the model you defined above. If you want, you could display the weights with something like print weights wait, is that a backslash? I always mix up. N curly brackets N bias N curly brackets format WB. I probably got all of that wrong. I don't either. Okay, so I think this is pretty easy. Because we just want the weights, right? What if we just like... Do you see... Oh, wait, am I supposed to print it? Give me a second. Oh! Haha. Whoa! I don't know what this is. Okay, it says, correct. Do you see how there's one weight for each input and a bias? Notice though that there doesn't seem to be any pattern to the values the weights have. Before the model is trained, the weights are set to random numbers and the bias for 0.0. A neural network learns by finding better values for weights. And then we have this. Fun. By the way, Keras represents weights as tensors, but also uses tensors to represent data. When you set the input shape argument, you are telling Keras the dimensions of the array it should expect for each example in the training data. Setting input shape equals to 3 would create a network accepting vectors of length 3, like 0.2, 0.4, and 0.6. Okay. Optional. Plot the output of an untrained linear model. The kinds of problems we'll work on through Lesson 5 will be regression problems, where the goal is to predict some numeric target. Regression problems are like curve fitting problems. We're trying to find a curve that best fits the data. Let's take a look at the curve produced by a linear model. You've probably guessed that's a line. Hold on, what's that last? Let's take a look at the curve produced by a linear model. You've probably guessed that it's a line. So it's not a line. Okay. We mentioned that before training, a model's weights are set randomly. Run the cell below a few times yet to see the different lines produced with random initialization. There's no coding for this exercise, it's just a demonstration. Cool. Okay, we have a line. Isn't it the exact same thing? Oh, never mind. It became positive slope up. Okay, now it's almost horizontal, no slope. Okay, now it's positive sloping again. Now it's negative sloping. Alright, cool. And that is the end for this one. All these exercises are going to be pretty short. I'll just do like a short walkthrough of each of these exercises. For my Kaggle videos. I hope you enjoyed the video, and I'll see you in the next one. Bye!